Hey everyone, this is 10.5, which is effects of changing dimensions. So what we're going to be looking at today is what happens when we change the dimensions of our figures. All right, so when I look here, I want to know what happens when to the area of the figure when I double the height of the parallelogram. All right, so the first thing I'm going to do is there's two ways we can do this. One, I can find the area of the original parallelogram, and then I can find the area of the parallelogram if I double the height, and then I can compare the two. Okay, so you always have the fallback of plugging in the numbers and finding the actual areas. However, it's not always the easiest thing to do. So if my area of a parallelogram is base times height, all right, if I double the height, that means that my area is going to be base times 2h. Well, if I manipulate these and I kind of rewrite things, this is going to be 2 times base times height. So I am taking that base times height, which is the original area, and I'm multiplying it by 2. So then I can say that the area is doubled. Okay, so sometimes the easiest thing to do is just plug the change into the formula and see how it affects the formula. All right, let's take a look at a second part, part B here. All right, we have a triangle with the given vertices, and we're told that the base is being multiplied by 1/2. So again, when I look at this, I can graph the points, I can plug it in, I can find the original area, I can find the new area and compare those. Or I could say, all right, well, if I have a triangle and my area is 1/2 base times height, okay? Well, now I'm going to take that base and I'm going to multiply it by 1/2. So it's 1/2, my base is half the length now, times the height. So if I, again, manipulate this so that I can see my original equation, it's half of my 1/2 base times height. So that means that my area is halved as well. We can say halved, or we can say it is divided by 2. That is fine. Or multiplied by 1/2. That is fine. Okay? So any way you want to say divide, cut in half, works for me. All right? So that's what happens if we're only changing one dimension. All right? So now what we want to look at is what happens when we change 2 dimensions. So we're going to look and see, all right, I have the base and height of a rectangle are both multiplied by 5. Now, I want to know the change on the perimeter and the area. All right? So I'm going to start with perimeter. All right? When I do my perimeter, all I'm going to do is add up all of my sides. With a rectangle, that's 2 bases and 2 heights. Okay? We could say 2b plus 2h, that's fine too. It's up to you how you really want to write it. I just stick with, I'm going to add up all the sides. All right? So now, if I multiply my base and my height by 5, that's going to be 5b plus 5b plus 5h plus 5h. So now I can factor out of 5 and get 5 times my base plus my base plus my height plus my height. So my perimeter is multiplied by 5. Okay? Let's take a look and see what happens to the area. All right, my area is base times height. All right, if I have 5 times my base times 5 times my height, that's going to be 25 times base times height. So my area is multiplied by 25. Recognize that 25 is 5 squared. Okay, so that's something that I kind of want you to pay attention to. We're going to talk about that in a minute. All right. So let's look at part B here. All right, I have a circle, and again, I want to find the change of, in this case, circumference and the area, what happens. All right, so when I'm going to look here, I have my radius is multiplied by 1/3. All right, so my circumference formula is 2 pi r. So if I multiply my radius by 1/3, I'm going to have 2 pi times 1/3 of my radius. Okay, and again, if I kind of manipulate this and I pull that 1/3 to the front, it's going to be 1/3 times 2 pi r. So my circumference is multiplied by 1/3. All right, now we're going to look and see what happens with area. So my area is pi r squared. So if I have 1/3 of my radius, it's going to be 1/3 r, and that is getting squared. So remember, that's going to mean that my 1/3 is squared and my r is squared. So when I square that 1/3, I'm going to get 1/9 times pi r squared. So my area is going to be multiplied by 1/9, which again, notice is 1/3 squared. All right. So notice in the last two examples, when all of the dimensions were changed, okay, my perimeter or my circumference was only changed by that factor. So in the first case of A, my height and base were multiplied by 5. So my perimeter was multiplied by 5. In the case of B, my radius was multiplied by 1/3. So my circumference, which is multiplied by 1/3. All right. If we look at the change in area, again, when all dimensions are being changed, when we look here, both base and height were changed by a multiplier of 5. So we squared it to get 25. Over here with my area, my radius was multiplied by 1/3. So my area was multiplied by 1/9, which is 1/3 squared. Okay, so that is going to lead us to this information. If all of our dimensions are multiplied by some number, the perimeter or circumference will be changed by a factor of that same number. The area is changed by that factor squared. But again, keep in mind that this must be all the dimensions. So a circle only has one dimension, it's the radius. But you've got your parallelograms, you have to be changed by base and height. Rectangles or triangles also have to be changed by base and height. It cannot be just one of them like in our first examples. Okay, our first two examples, we only had one dimension changed. Okay, this is true when all the dimensions are changed by a certain factor. All right. So what we're going to do here is we're going to kind of take a look at it a little backwards. Okay, what happens if I say, okay, I tripled my area, what happened to my side length? So sometimes in problems like this, it is actually easier to find the actual areas and find the true information and then compare. Whereas in the first ones, it's easier just to kind of plug it into the formula. I do want to show you a couple examples where we are plugging in actual numbers. So what we're going to start off by doing is we have a square and its side lengths are 5. So I'm going to find the original area. All right. So the original area, remember, is base times height. So our area is going to be 5 times 5, which is 25. Okay, so our original area is 25 square centimeters. So now I want to know, okay, I'm going to triple my area. So 3 times my area is going to be 3 times 25. And that's going to give me a new area of 75 centimeters squared. Okay, so this is my new area. So now I want to know, okay, what happens to the side length if I have an area of 75? Well, notice here when I do base times height that I'm really doing side squared because it is a square and their base and their height are the same. Okay, so I'm going to say for my new figure that my area is going to be side squared instead of base times height because again, the sides are the same. Okay, so my area for my new figure is 75. I want to know what that happens to my side. So I'm going to get my side length by itself. So I'm going to square root both sides. So the square root of 75 is going to be the side length. Now, I want to go ahead and put this in simplest radical form. So the square root of 75 is the same thing as saying the square root of 25 times the square root of 3. So the square root of 25 is 5. So this is 5 times the square root of 3 is my side length. All right. So that means that my side length, when I look, my original side length was 5. My new side length is 5 root 3. So my side length is multiplied by the square root of 3. And again, if we kind of come back to this chart, if my factor that my area changed by was 3, 3 is my a squared. So that meant all the dimensions were multiplied by the square root of that, which is the square root of 3. All right, my perimeter circumference would also be affected by the square root of 3. All right. So we're going to do another one. And again, I kind of want to show you, we can still work it without doing the actual formulas and without using the true numbers. But again, I still kind of want to show you what happens if you plug in numbers. So we could still do this again without using the numbers, but I do want to have you at least see what using the numbers does look like. All right. So I have a circle that has a radius of 6 inches. If the area is doubled, I want to know what happens to the circumference. Okay, so 2 things. I need to find with the original figure, I need to find the area and the circumference, okay, because I'm doubling the area, so I need to know the area. I want to know what happens to the circumference, so I want to know the actual circumference length. All right, so my original area is going to be pi r squared. So it's going to be 6 squared times pi. So my original area is going to be 36 pi. Okay. My circumference for my original is 2 pi r. So it's going to be 2 times 6 times pi. So my original circumference is 12 pi. All right, so now I'm doubling my area. So 2 times my area is going to be 2 times that original 36 pi. So my doubled area is 72 pi. So what I want to know is with my doubled area, what is my new circumference? Or what is my new radius, excuse me. So my area is pi r squared. I know that my area is 72 pi. Okay, so this is me here. We're solving for what the new radius is when that area is doubled. Okay, for our newer figure. So what we're going to look at here, we divide both sides by pi. We get 72 is equal to r squared. Again, we square root both sides. And 72 is the same thing as saying the square root of 36. times the square root of 2. And the square root of 36 is 6. So it's 6 times the square root of 2. Okay? So my radius, if I compare the original radius to the new radius, my radius has been multiplied by the square root of 2. So now we're going to look at what happens to the circumference. Circumference is 2 pi r. So my circumference is 2 times 6 times the square root of 2 times pi. This is going to give me 12 times the square root of 2 times pi. So this is my new circumference. This was my original circumference. Okay? So I have taken my original circumference and multiplied it by the square root of 2. So that's what our change is here. So our circumference is multiplied by the square root of 2. Again, if I pop back to our little chart, my area changed by 2. So my a squared is 2. That means that the change in the dimensions and the change in perimeter or circumference is the square root of 2. Okay, so this is part A and part B. So again, we could have done that by using this chart and kind of working backwards. But I did, again, want to show you how you could use actual numbers if any of that gets confusing working with the true formulas. All right. If you have any questions, make sure you write them down, and I will see you guys later. Have a great evening.